Alrighty guys, let's go ahead and take a look at this problem right here. This one says that a boy does 120 joules of work to pull his sister back on a swing that has a 5.1 meter chain until the swing makes an angle of 32 degrees with the vertical. So there's a lot going on in this problem. We want to figure out what the mass of his sister is, and we want to use 9.8 as the acceleration due to gravity. First thing I recommend doing is drawing a picture. So if this is my swing, the chain hangs down like this, but then the child is pulling his sister back to some angle that they told us, which was 32 degrees. So now his sister is right here, and this part of our triangle is our chain. So the chain we know is 5.1 meters. And it wants us to figure out what the mass of his sister is. Again, the work that the child does is 120 joules of work. And the way that we're going to solve this is by figuring out how that work is being done. Well, that work is being done against gravity. So we know that work is equal to F times D times cosine theta. So in other words, the energy that's happening here due to that work is coming from gravity. So work is really equal to mass times gravity times height. And the question is, how much height is this child pulling his sister back with? Well, we know that the chain, when it lies flat, is 5.1 meters long, but when pulled back, we can see that we are missing some height here. So this part right here is our missing height. So let's go ahead and solve for that. The way I want to approach this is I want to take our vertical axes right here and then attach our horizontal axes right here. So we have our angle, we have a vertical, we have horizontal, and we have our hypotenuse. The vertical side is going to be our adjacent side, and we're going to go ahead and solve for that. So we know that cosine of our angle, so cosine of 32 degrees, is equal to adjacent over hypotenuse. The hypotenuse is 5.1 meters. So in order for us to solve for the adjacent, we're going to multiply 5.1 over. We get 5.1 times cosine of 32 is equal to our adjacent side. If we plug this into our calculator, go ahead and do that really quick. 5.1 cosine 32. I end up with 4.33 meters. So my adjacent side is going to equal 4.33 meters. So why is that important? Well, like we said before, the work being done is due to gravity. So the height is going to be this missing part here. In order for us to figure that out, we know that the chain, when fully loose, is 5.1 meters. And now we just figured out what this height is from here to here. So the adjacent side is 4.33 meters, and the total length, so I'll go ahead and draw this again. So the adjacent from here to here is 4.33, where the total length of the chain is 5.1. In order for us to solve for the height, this missing side right here, we're just going to subtract the two. So we find out that h is going to be equal to 5.1 minus 4.33. Plugging it into our calculator, we get 5.1 minus 4.33 is equal to 0.77 meters. Now we need to go ahead and solve for the mass of the child sister. And to do that, we said work is equal to mgh. If we're solving for mass, we're going to divide gh. So we find out that work over gravity times height is equal to the mass. All we need to do is plug our numbers in. The work is 120. Gravity is 9.8. The height we just solved for is 0.77. Therefore, giving us a mass, 120 divided by 9.8 times 0.77 gives us a mass of 15.8. And we know that mass is in kilograms. So definitely a very tricky problem, but a very doable problem. We just need to kind of think outside the box here.